welcome back. I wanted to make a short video describing what a Newton was, because I get a good deal of confusion from students every now and then because the unit analysis doesn't work out if you just think of it as newtons. In other words, I have Newton's second law on the screen right now, but if I lay this out in units, I'll get meters per second squared for the acceleration. Force, of course, is newtons, and the mass is in kilograms. And looking at this straight out, the unit analysis doesn't really work, which confuses first-year physics students sometimes. So I'm going to show you what a Newton actually is. And to do that, I'm first going to rearrange second law. Just multiply mass on both sides. I get F net equals mass times acceleration. You'll actually typically see it drawn this way because it's very easy to type out on a word processor. So I'm going to start with this. Mass I'm going to keep. Acceleration, I'm going to use the actual definition of acceleration, which is change in velocity over time. I'm going to expand that. I get mass Vf minus Vi over delta t. So this is mass times acceleration, and if you recognize it, this is the second kinematics formula. Okay, now I'm going to take this, and I'm going to do this with numbers and units instead of the variables. So here's the basic idea. When a standard unit for force was being sought, an experiment needed to be done that matched with the units that we already had. So the idea was if we take 1 kilogram, a 1 kilogram object, like a physics card, and we accelerated it from rest, so VI would be 0 meters per second, to a final velocity of 1 meters per second, and we did that in exactly 1 second, how much force would that take? And the consensus was, however much force that took, that would be 1 Newton. Now, why did we use newtons? It's because here is the actual unit. If I was to reduce this, this would be kilograms times meters per second, this is divided, squared. So this would actually be 1 kilograms times meters per second squared. That's the actual unit. So every time you write down Newton, you are actually writing down this. This unit was simply given a different name. It was obviously named after Sir Isaac Newton. And one of the reasons probably was writing this down every single time would be a pain in the butt. So instead of writing kilograms times meters over seconds every single time, they said, we'll just make it a Newton. So 1 Newton is actually this. So if I rearrange second law here for mass, mass equals force over acceleration. Force actually is kg m over s squared over acceleration, which is meters over second squared, and everything cancels and you get kilograms. So long story short, a Newton is actually this unit. Every time you write down a Newton, you're actually writing this. If you ever want to do the cancellations for the units, you can literally switch this out. So if you have a problem with Newtons and you want to see how the units work out, literally take Newtons and replace it kg times mass over seconds squared. You can write it like this as well. All right, hopefully this helps get rid of a little confusion. Have a good day. This is Mr. M signing off.